Hello, how are you guys? Hope you are doing fine in this calamity. And I thought let's that I should make some videos regarding our subject so that it can be clear to you whatever the notes I have provided. So you have to go through them and you have to go through all the tutorial sheets. Okay, and plus all the video lectures that I have provided from Gate Academy, you can that will also help. So whatever the notes I have provided for that I will provide the video lectures. Okay, so let's start our course. So that is basically your strength of materials, and let's revise some basic principles. So as you have my notes that I have also provided on Google Classroom. Okay, so let's start. So what is engineering basically? Its basic the meaning of the engineering is to innovate or to build new things. Okay, so that you have to design that. So according to the basic need or who is going to use that. So that's basically the design for any designing anything. Yeah, you have to know the different aspects of that material or that assembly that you are going to design. So we have two basic aspects that will cover the designing philosophy basically. So first is your function aspect and functional aspect, and second is your structural aspect. The functional aspect take care of design usage. Okay, so who was going to design, who is going to design that, and suppose means a bed is there or something, a building is there. So what is the loading capacity of that bed, or for what purpose that building is being used. So according to that it has different structures have different functional aspects. Okay, so like hospital, building, shopping complex. So there are so many types according to the need of the owner or what who is going to use it. According to that you have to design it. Okay, and also the second is your structural aspects basically. So it should whatever you are going to design, it should be able to hold whatever the loads is there. So it should be able to withstand those loads basically, and it should serve its purpose. So we have two types, two structural aspects basically: strength capacity or strength capability basically. So and the second is your stability. Okay, so the structure or a mechanism that you are going to design should be stable. So for that what we have to know basically, you have to know two things. The first is your material property, which what material you are going to use. So according to that material, each material have their own mechanical properties. So you have to know all the mechanical properties regarding to that, so that you can use effectively. And you should know that how much material you are going to use or you have to provide, so that it can withstand the load. So second is your structural equilibrium basically, that will deal with the stability problem. So stability should be there, so that what who is going to use it, so it can use it fully. Okay, so structural equilibrium for the stability should be maintained. So if your mechanism is at rest, basically the momentum linear momentum is zero, or you can say that it is not accelerating, the body is not accelerating. So all the forces that are coming onto the body, that will adhere to the static equilibrium equations. And if your body is moving or mechanism is moving, so it will means it will be adhering to the dynamic equilibrium equations. Okay, so this basic thing is basically studied in mechanics. So that's why we also call it as mechanics of materials basically. So mechanics is a field that deals with the means analysis of the forces or loads that are coming onto the body, and what are the basic deformations are happening inside the body, or what is the value of stress or force that is going to develop inside the body, that will be governed or studied in the mechanics part basically. So in our course we have static equilibrium. So all our body, all our mechanism adhere to the static equilibrium. Okay, So we have basically already told you in the previous lectures, that we have means on the body, on a body it can be we can apply forces or moments on a body. And for a static equilibrium, the body should be following the static equilibrium. For that, all the forces in x, y, z direction, and all the moments acting about those direction in x, y, z, sigma fx is equal to 0, sigma fy is equal to 0, sigma fz is equal to 0 should be okay. And these all the moments should be 0, or you can say all the forces and moments are nullifying each other, so that the shape, or the body is at rest basically, so body is not moving anywhere. So that's the thing, you have to check the body first, so that you can apply the equilibrium equation. Okay, so the only if your body is at rest, then you can only apply the equilibrium equation here. So yes, what are the various basic types of the means forces and moments, and types of supports and constants that I have also means covered in the introduction lecture. Let's go there and see what are the various things are there. So moving through, so we have these material properties. You can already means go and study there. We have various lot of material properties are there. Elasticity is there, plasticity is there, ductility, brittleness, toughness, hardness. So these are the basically mechanical properties of a material that you are going to use. So it will help you in the designing in the any assembly. And what are the force basically? So see here, this is diagram over here. The body is there, arbitrary body, and there are various types of force are acting on it. So we have divided in two types basically: surface force and body force. So surface force, it will be actually basically acting with the contact of the two bodies. When two bodies are in contact with each other, then surface forces will apply, and body force will apply even without the contact, like gravitational force or magnetic force or electrostatic force. Okay, so in surface force we have three types basically, and these are the forces we are going to study. Surface force, we have concentrated force that is acting on a particular point, and second is your UDR, uniformly distributed or uniformly varying force, that is basically load that is being varied along a length of the line. Okay, and then there is a pressure force or surface force, you can say, that is basically your pressure surface force, and this is basically your body force, that is basically gravity or weight due to gravity. Okay, so we have different types of constraints basically to hold the body in this position so that it cannot move anywhere. Okay, so we have four types of supports: roller support, pin support, sliding support, and fixed support. So each is having their own constraint basically. That suppose this is roller, so it will give you one constraint in this vertical direction basically. So the support is free to move in horizontal direction, but it cannot go in vertical direction. Also here in this condition, this roller support is there, so support can't go in x direction, and it can go in y direction. Okay, this is inclined basically on the inclined surface, so you have to see the reaction will be always be perpendicular to the surface, so you have to resolve the component and see and analyze the support reactions. Okay, and this is basically your roller support in 3 dimension. So whether it in 2 dimension or 3 dimension, it is always going to impart 1 degree of constraint, means one reaction at that particular angle, means and also for the you have to means resolve the components in x and y and z, so you can calculate the actual values over here. So this is pin support. You can also see here that there it will always give you 2 reactions, and this is the basic another form of pin support. This is the 3D form. So in 3 dimension, pin support will give you 3 reaction. Okay, in 2 dimensions, pin support will give you 2 reactions at support. So these are basically unknowns that you have to calculate by using equilibrium equations. So let's move So this is your sliding support. So it will give you two translation reaction and one moment reaction. The body is not allowing it to rotate and nor translate. Okay, translate, sorry, this is fixed support and this is sliding support. So the body can go in y direction, but it cannot either rotate or it cannot go in this horizontal direction like this gantry crane. It can just slide over here. Okay, coming to the fixed support, so what we have here is, so body is fixed, clamped in the ground, okay, or clamped in the ceiling or clamped in the wall. So it cannot neither rotate nor go anywhere. So we have two reactions over here and one moment reaction. Okay, so this is in 3 dimension basically. So you have 6 translation reaction and, sorry, 3 translation reaction and 3 moment reaction, giving total to 6 basically. So in 2 dimension we have 3 support reactions and in 3 dimension we have 6 support reactions. Okay, so state of equilibrium requires this 2 equation to be necessary. Summation of all the forces should be 0 and summation of all the moments should be 0. And in 2 dimensions what we have here is, we have means only 3 equations: sigma fx is equal to 0, sigma fi is equal to 0, sigma m omega or mz is equal to 0. This means that our body is lying and all the forces acting on it lying in one plane. Okay, and in 3 dimensions we have 6 equations to solve. And what you are going to solve, basically you have to solve the external forces, basically means the support reactions. What are the unknown support reactions are there, and we have internal forces, moments in the body that is going to develop due to external loads. And basically after that we will going to calculate the deformations in the body like elongation and compression. So let's see what other things are there. Okay, so yes, see, deformation in the body is basically, so due to the external forces or moment that is being acting on a body, so we have internal forces are going to develop inside the body as a reaction force. Okay, so we have different types of forces and different types of moments that are going to act inside the body. Okay, and we have what, where first is your axial force or normal force, that is basically acts perpendicular to the surface. Okay, or you can say acts along the longitudinal axis of the member. And in tangential force, that will act parallel to the surface cross section and acts in line in the transverse axis. Okay, so what axial force does, it either creates, it will be elongating the body or contracting the body. It will depend upon the type of the force, whether it is tensile or compressive. So axial forces are basically responsible for change in volume, and tangential forces or shear forces that we got call it as, and they are responsible for the angular distortion, that is basically your change in shape. So remember that. And we have 2 types of moments, basically bending moment and twisting moment. So how a moment will develop, basically if you are applying a moment about longitudinal axis of a member, then it will develop twisting in the body. Okay, and that is also called torque. So acts about longitudinal axis of the body and it will generate twisting in the body. And in bending moment, when it will apply, it will apply when you are going to apply moment about transverse axis of the body. Okay, so this will act about transverse axis of the body and it will develop hogging or sagging. Basically it will curve the shape of the body. So there will be stresses generated over there. Either it can be compressive stress or tensile stress based upon the location you are going to calculate it, basically. Okay, so this is basically your sign convention, what we have already discussed, that if a body is subject to various forces, so what you can do is, you can just, if you want to interested in means calculating forces or moments at this particular section or at a point, so just cut it here. Then we have your left hand segment and right hand segment, and then apply all the means what are these. Basically these are basically the assumptions that we are assuming that at this particular cross section of the body we have one normal force, one shear force, and a moment acting here, and basically this is the equal and opposite reaction that is going to apply in this section, so that it can be defined. So this RHS, basically this is your free body diagram, and after applying equilibrium equations here, you can calculate the value of internal forces and moments that are going to develop at this section XX. Okay, so what we assume over here is, we assume that we always assume that means normal force is acting in tensile direction, means it is tensile, and shear force in this downward positive direction, and moment it is causing due to, means there is a sagging in moment, means there is a sagging is happening in the body. So this is a reaction for, means reaction moment for the sagging that is being acting, means sagging moment that is being acting at this particular cross section. Basically it will be acting at the certain point. Okay, so next is, means how you have to calculate, means stress in the body. So what is basically stress, how, means as we have already done the various tutorial sheets, so that you can calculate all these internal moments and support reactions and internal forces. Okay, so let's move on to the stresses basically. So what is stress? It is basically the stress is relates, it relates to the geometry of the body. How it is going to relate, means it will give you the dimension, means what is the amount of pressure that is being developed due to that force at a particular point or at a particular cross section of the area. So stress can be defined as the intensity of the loading that acting at a particular point. Means suppose if you are applying a force over here, that is basically your tensile force. So this is normal force is acting over here, so it will generate and means normal stress. Okay, so we have two types of stress as according to the forces that is we are going to apply over here. So we have axial forces and axial forces will generate axial stress or normal stress that we call it as. So it either can be tensile or compressive, and it is shown with the sigma sign, and this will be equal to n upon a. And transverse shear forces or shear forces, basically it will generate shear stresses in the body, and where it will act in the along the cross section of the body, means over here. Okay, so this is basically the denoted by tau, and it will be equal to the V upon a. This is basically your shear force, and this is a is your area of the cross section. Okay, and what is strain in the body? It is basically the measure of deformation. So when you are applying a load over here, so what it is doing, basically the body is deforming due to this external load. So that is how you can calculate. So all the normal force will result in elongation and contraction. Basically this is your change in volume, and two strains that you are going to calculate due to this normal stresses, basically or normal force, you can say that longitudinal strain, that is basically change in the length of the body along the longitudinal axis, and lateral strain is basically change in the width or height of the body along the transverse axis. Okay, so remember this, longitudinal strain is basically along the longitudinal axis of the member, and lateral strain is basically along the lateral or transverse axis of the member. And this Poisson's ratio is basically given by the Poisson, that is basically the ratio between lateral strain and longitudinal strain. So Poisson's ratio will be given as a point the lateral strain divided by the longitudinal strain. Okay, so it is having value from 0 to 0.5, and sometimes it gets negatives also in various materials, viscoelastic materials as other are there. So change in shape, so means shear deformation, shear stresses, what they will do, they will try to distort the shape. So angular deformation is can be given by gamma. Basically what is this, this is shear strain, and what gamma, how can you calculate it? Suppose this is a shear is being applied on this body and the shape is being distorted over here. So previously the angle was 90 degree, and now the angle is less than 90. So if see what how you can calculate it, basically you can calculate it by means subtracting the original angle subtracting the current angle from the original angle. Okay, original angle minus current angle. So previously it was pi by 2 means 90 degree, and now it is theta. Basically this is your acute angle theta, sorry, means the difference will be positive. Okay, because 90 degrees should be greater than theta, will be greater than theta. And at B over here, so this is obtuse angle. So previously it was 90 degree, and this will obviously this will be greater than 90, so it will be negative. So this is how we just denote it as positive and negative shear strain. What is Hooke's law? Basically, Hooke's law is basically given by the Robert Hooke, and it states that the means within elastic limit, stress, the value of stress and at a particular point in the material is going to be directly proportional to the value of strain in the material, and this can be given as like sigma is equal to E into epsilon. What is E? Basically, E is the Young's modulus of elasticity, and this is the basically material constant. And for shear stress, we have the same expression. Shear stress is equal to G. This is modulus of rigidity into shear strain. So, how can we calculate E and G basically? So these are the material parameters that you have to calculate by plotting a stress strain curve. And what is this? This is basically is your graph between stress and strain. So when you are applying a means force, or you are going to pull a body, and you first basically you have to do tensile tests. Okay, so these are the standard tests that you have to perform on samples of the material that you are going to take, and there is a standard shape over there. You can go and see in the book, or also there are so many means I have also uploaded one video regarding that on my website. It is there, and you can go and see regarding the stress strain, how to plot that. So what you have to do is in universal testing tensile testing machine, we will procure the material and draw lathe it out, and you can say in the shape of the standard specimen. Then what we will do is we will apply tensile loading over here. So basically what we'll do, whatever the amount of strain that is going to you are going to calculate over here is, so we will calculate strain and load also. So load upon area will give you the stress, and strain you can calculate by change in length upon the original length. So according to that, after that you have to do, you have to plot these values, stress versus strain. So there are two graphs basically, engineering stress strain curve and true stress strain curve. Okay, so in engineering stress strain curve, what we have is sigma is stress being calculated by using original area, means what was the time before you are going to apply the load, you have applied the load. And in true stress strain curve, what we do is we calculate stress by using current area. Means what is going to do is, when you are going to apply the load, this is going to stretch and this area going to decrease. So you have to calculate that decrease in the area by extensometer is there, and also you can calculate after using strain gauges and all the things. So you have to plot that. For calculating E and G, we can generally calculate it from engineering stress strain curve. So we have to plot it, and we have to see the linear variation, means where the linearity is there, and that is basically your elastic limit. Okay, so up to the elastic limit there is a variation will be linear. So we will draw a tangent over here, then we will calculate the slope of that line. That slope of that line will give you the value of modulus of elasticity. And similarly with the graph from shear stress versus shear strain, and we will have same behavior over here also, and we will calculate slope of the line, okay, initial tangent line, and calculate the modulus of rigidity. So this is how you can calculate the mechanical parameters of the material. So various parameters are there. So this is basically basically this is related to your elasticity, and hardness is there, toughness is there. So basically hardness, what is hardness? Hardness is the means resistance to abrasion, surface abrasion. Okay, so that is there are various different tests are there. Okay, so what is basically ductility? Ductility is a measure of means how much your material is going to elongate before failure. So higher the elongation, higher will the ductility, and this is also means differentiate ductile materials from brittle materials. Okay, so percentage of elongation that you can also calculate from this formula. This is basically governed from here, and you can derive it easily over here. So this is it for the review lecture. Okay, so let's in the next lecture we will discuss stress in more general format. Okay, thank you.